Hello, dear students. Greetings of the day. I, Mohammad Zishan, welcome you to the online classes of Blooming Birds Code School, Sambal. Uh, Dear students, today we are going to study the third chapter, Rotation and Revolution, and this is the third lecture for this chapter. In last chapter, we studied about the effects of rotation, and in this chapter, we are going to study about the inclination of Earth's axis and its significance. Now, what is the meaning of inclination? Okay, we will begin this chapter by this lecture by understanding the meaning of inclination. Inclination means to incline or means to bend towards or away, right? To bend towards or away. Like suppose this is a line, okay? This is having a 90-degree angle. A man is standing in this manner, okay? He is standing at the angle of at 90-degree angle, okay? Getting or not? And suppose if a man is bowing towards someone like this at an angle of 66 and half degree. Clear? 66 and half degree. So this person is inclined towards this man, okay? So maybe some Raja or something, okay, like this. Okay, bowing towards Raja, right, king, in that manner. So this is called inclination. This is called inclination, right? And this is called tilt. This is called tilt, okay? 90 degree minus 66 and half degree will give you 23 and half degree. This is the tilt, okay? Tilt from the perpendicular, okay? Tilt from the 90 degree. A man is straight means a man is perpendicular to the ground, right? And if he got tilted by 23 and half degree, right? This 23 and half degree, then it means that man is bowing or inclined towards that king at an angle of 66 and half degree. Let me check the video. It's going good. Uh, Before recording this video, I taught this entire chapter, okay? But when I checked my mobile, it was not being recorded. Memory was full, and now again I have to teach you these things again, okay? So these problems takes place while recording lectures. So it's there. I hope you would have understood the meaning of inclination. Now we will study about the inclination of Earth's axis. Now what is axis? Axis is an imaginary line which passes through the center of a rotating object. Like suppose this is a lattu, right? Lattu, why? Because I have rotated lattu a lot during my childhood. That is why I am giving you this example. It is a conical shaped, okay? And suppose if it is rotating this in this manner, right, like this, then this will be the axis of rotation, right? This will called axis of rotation, and around it this lattu is rotating, okay, like this. It is rotating in this manner. Clear? So likewise, Earth is also rotating, and the line which is perpendicular to its rotation, you can say, right, and passing through the center, that line is called axis of Earth. Clear? So suppose this is Earth, right, and this is center of the Earth, right, and Earth is rotating in this manner. Clear? From west to east, right, in this manner. Clear? Then this will be the axis of the Earth. Clear? This will be the axis of the Earth. Now it is 90 degree, or you can just make angle here also, okay? It is 90 degree, both are same thing, okay, right? but Earth's axis is not at 90 degree. It is not rotating in a its axis is not perpendicular, it is not rotating this way. Okay, you can see, I can show you the globe. Okay, what what is this? This is the plane. Okay, the plane in respect to the orbit of Earth's revolution around the sun. Clear? So from here, if you will count, right, this thing, if it is like this straight, then it will be perpendicular. Okay, it will be perpendicular, right? But Earth's axis is not like this. Earth axis is this way, right, at an angle of 66 and half degree. So if you draw an angle of like this, okay, from here, angle that will be 66 and half degree, right? This is sun, so it is inclined towards sun, right? If it was like this straight from here, from this bottom, as you can see, this one point, if it was like this straight, right, then it would called the vertical or perpendicular axis. Okay, but the axis of the earth's rotation is not vertical or perpendicular, but it is inclined at an angle of 66 and a half degree, and hence it is tilted from the perpendicular by 23 and half degree. Okay, so if question comes ke, what is the tilt in the earth axis, then you will write 23 and half degree. earth Earth's axis is tilted by 23 and half degree from the perpendicular, okay, to the plane of the to the plane on which earth is rotating. Okay, and when it is asked what is the angle of inclination of Earth's rotation, that will be 66 and half degree. So you have to remember these two things: tilt 23 and half degree, inclination 66 and half degree. So Earth is not like this. Earth is not like this. Rather, Earth is in this manner, as I have shown you on globe. Earth is rotating this way. Suppose this is the center of the Earth. So Earth is rotating this way. Clear? This is the angle, okay, 66 and half degree. Okay, this is the plane. Okay, this is the plane. These two I have drawn here, I have taken, or here I have taken perpendicular line. Okay, this is the plane. This plane is drawn in respect to the orbit of the earth. Okay, which is right. Earth is rotating around the sun. Clear? In this manner, right? It will be the same. It will come here also, it will come here also, it will come here also, right? Clear? So in respect to that orbit or path, right, in that plane, the angle of the earth's rotation is 66 and half degree, not straight, not straight. You can draw here also and you can draw here also. Okay, not straight. Clear? It is not straight, right? It is not straight or vertical, it is not perpendicular. Okay, it is not at 90 degree, and hence it is having a tilt of 23 and half degree. Why? Because 90 minus 66 and half degree will gives you 23 and half degree, right? This is the tilt in the uh, axis of the earth from the perpendicular drawn to the plane, okay, of rotation. This is the plane of rotation, and regarding in respect to this plane only, we are measuring the angle of axis, earth's rotation. Okay, earth's axis, right? And this is 66 and half degree. Now after understanding this, what is inclination, what is tilt, what is axis, and why, how many degrees it is tilted, right, and inclined towards the sun, we will study what are the effects of this tilt, right? What are the effects of this tilt, and what would have been if the axis of the earth was straight or perpendicular, right? If this was not inclined at an angle of 66 and a half degree, if it was straight like this, if it was straight like this, then the sun rays would have fallen straight on this region, equator, and nearby areas throughout the year. Okay, throughout the year, and this would have been remain the position of the earth, right? And these places would have received the slanting sun rays. Okay, and duration of days and nights would have remained equal throughout the year. So when duration of day and night will remain equal throughout the year, there will be no variations or change in season. There would have remained only same season, okay, at places, different places, right? If it was summer here, it would have remained summer. If temperature is low here or moderate here, then temperature will remain moderate throughout the year. If here temperature is low, then it would have remained winter season here, okay, throughout the year, right? So one season will remain throughout the year at different places, okay. So as the sun rays, as the axis of the earth will be straight or 90-degree or perpendicular to the plane, then what will happen? The sun rays will fall directly on this line, okay, on this, right, on equator, right, and this region around equator will become very warm, very hot, okay, and this will receive the sunlight in same fashion throughout the year, and hence it will become very hot, and these regions will receive sunlight. The sun rays will fall slantingly over these places, right? Sun rays will not be perpendicular because sun rays are perpendicular here and earth is spherical. So here at these places, what will happen? The sun rays will fall slantingly in slanting manner, and because of that, what will happen? Because of that, these places will become very cool, right? And here the winter season will remain throughout the year, and here the summer season will remain throughout the year. And at these places which are near the mid latitudes, which is around 45-degree or 45-degree to 50-55-degree, starting from even 35-degree, these places will receive moderate temperature, okay, because of the moderate angle of the sun rays, and the life will exist only on these places, okay. These places will be suitable for living, okay, starting from 35-degree or 40-degree to 60-degree latitudes, and rest places, either the places near the equator or the places near the poles, these two places will become very hot and very cold respectively, right? So if the earth is not inclined at an angle of 66.5 degree, if it is perpendicular, then which two things we will get? The duration of day and night will remain same. This half of the globe will receive sunlight for 12 hours, and then for next 12 hours this half of the globe will receive sunlight. So duration of days and nights will remain same, and then there will be no change or variation in season. Season will also remain one, okay, or same. If it is summers here, it will remain summer. If it was winter here, it will remain winter throughout the year, okay. And the only few places over the earth will be suitable for living, okay. Life will exist there only, this I have told you. Now we will study mathematically how inclination of earth, right, uh, is responsible for the change in duration of day and night. So first we will begin with the first condition, hypothetical condition, that if the axis of the earth was perpendicular to its plane, if it is at 90-degree, okay, if it was straight like this, then what would have been the conditions on earth? That we will study, that hypothetical condition we will study. Then after that we will study the real conditions, okay. The first thing, suppose this is the earth, right, and I am assuming that the axis of the earth is straight like this. This is center of the earth, right, and it is how much? 90-degree. 90-degree, here 90-degree, okay, same thing, clear? Now this line is 23.5 degree, I should write here 23 and half degree south, and this is 66 and half degree south. This is Tropic of Capricorn, this is Antarctic Circle, and this is 90-degree south pole, and this is 0-degree equator, and this is 23 and half degree north, that is Tropic of Capricorn, Tropic of Cancer, and then this is 66 and half degree north Arctic Circle, and this is 90-degree north pole, right? I will take this point as A, this point as B, this point as C, this point as D, this point as E. After 12 hours, what will happen? The Earth will have complete rotation, and this A position will come here, it will become A dash. So I will take it B dash, I will take it C dash, I'll take it D dash, I'll take it E dash. Clear? Now these points I'll take this point as P, as Q, as R, as T, as S, and as T. Clear? P, Q, R, S, T. And from here the sun rays are falling, okay, right, like this. The sun rays are falling in this manner. Clear? So this entire region, the half of the earth, right, will receive sunlight. Clear? This entire region will receive sunlight. So I should give you demonstration now, right? This is earth, and the axis of the earth is like this, suppose, okay, straight, right, and this is sun. Clear? Now when sun rays will fall, so the half of the earth, okay, this much and this much, right, it will illuminate for 12 hours, it will receive sunlight, and for next 12 hours the back of that will receive sunlight. So means half of the earth will receive sunlight, right, for 12 hours, like this. Clear? And now this is clearer to you, right? And as I have drawn lines of latitudes which passes through various regions of the earth, this is passing through center, this is passing through 23 and a half degree Tropic of Cancer, through India, okay, and this is 66 and a half degree Arctic Circle. Means one line is passing from here, this region of the earth, another is passing through here, this region of the earth, right, and another is passing through here, this region of the earth. So I have taken various places of the various parts of the earth to show, okay, what is the duration, right, of day and night at those part, what is the duration of day and night at this part, what is the duration of day and night at this part, what is the duration of day and night at this part. Okay, so as you can see that the half of the earth is receiving sunlight. This is hypothetical condition, okay, this is not actual. Earth's axis is not at 90 degree, okay, just we are assuming, okay, it is 90 degree. Clear? So now I know that, okay, RC is equals to C dash R, okay, or CR is equals to C dash R. It means at equator the length of day, this is day and this is night. The length of day and night, this CR is equals to C dash R, okay, so both are equal. Likewise here the Tropic of Cancer which passes through India also, right, so BQ, length of line BQ is equals to BQ dash. Achha, we should take it in same manner as we have taken CR and C dash. So we can say BQ and B dash Q equals, right. Likewise AP is equals to A dash P, okay. Likewise DS will equals to D dash S, okay. Likewise ET will be equals to E dash T. Clear? So now you can see that this is the length of day and this is the length of night. So length of day and night both are equal mathematically, as you can say here, okay? Right? As you can see here, the length of day and night is equal. So now what is happening? What will be its effect? Day and nights are equal. Length of day and nights are equal. So it means the places will receive same amount of temperature, right? And it will leads to what? Same season. There will be no change in season, or same season will be there, right? No change or variation in season will be there, right? This will be the effect or impact of this straight axis of the earth. Now what we will do? Now we will take the second condition. The second condition is actual condition. It is not hypothetical condition. Here the earth's axis is inclined at an angle of 66.5 degree. Okay, it is actually inclined. Clear? So what we will do? We will now draw again. This is earth. Okay, and कुछ ज़्यादा गोल बन गई. Okay, let it be a rotten tomato. Okay, right? Now, suppose this is earth, right? And this is the center of the earth. Clear? Center of the earth. Now, we know that suppose this is the plane of the earth, right? Earth rotation, and this is the 90-degree perpendicular, right? And we know that earth is not rotating in this manner. The earth is rotating at an angle of 66 and half degree. Okay, at this angle, this is 66 and half degree. This is the angle of inclination. Here also you can have that angle by drawing a line like this. Okay, just parallel to the plane. Okay, this is 66.5 degree. Here this will be 66.5 degree if you measure, and it will be 23.5 degree. Okay, so we will erase all these things, right? Acha, let me show you one more thing clearly so that you will understand. This is perpendicular to the plane, right? Or the plane or the area or the path on which earth is revolving around the sun, and that is 90 degree, right? But the earth is not rotating in this fashion. In this fashion, it is not rotating in this fashion. How earth is rotating? Earth is rotating at an angle of 66 degree. Okay, it is not rotating like this. Okay, it is not rotating like this, although, but it is rotating like this. Okay, like this. So earth's rotation is in this fashion. Clear? Not in this fashion, right? So earth's rotation is in this fashion. So we will draw a line. This will called what? 0 degree equator, right? 0 degree equator. Another line, 23.5 degree north tropic of Cancer, 66.5 degree north Arctic Circle, 23.5 degree south. This is Tropic of Capricorn, 66 and half degree south. This is what? Antarctic Circle. Clear? So in this manner. Now what we will do? Now we will just name these lines like we have named earlier. So this will be A, this will be B, this will be C, D, and this will be E. Likewise, it will be A dash, this will be B dash, this will be C dash, that will be D dash, and this will be E dash. Clear? And this is the North Pole, and this is the South Pole. Clear? And right now we will do what? We will just draw sun here like we drew earlier, and the sun rays will fall on earth, right? In which manner? In this manner, and half of the earth, okay, half of the earth will be illuminating this manner, in this manner. Clear? In this manner, right? And these points, this will be P, this will be Q, this will be R, this will be S, and this will be T. Clear? Now you can see that okay, earth is rotating in this manner, right? And here this much region is not, from here to here, not receiving sunlight, okay, and this much region is receiving more sunlight, okay, clear? So here mathematically we can prove that okay, the places which are near the equator or exactly on equator, like CR is equals to C dash R, as you can see here, okay, this area is receiving sunlight, okay, CR is equals to C dash R, okay. So this is day and this is night. Clear? So at equator the days and nights are equal. At equator days and nights are equal. Then here we are having this BQ. Sorry, we have taken, we have to take this P and Q where, till where the sun rays are falling, okay, in this here, up to here. This is P, this is Q, and this is R, this is S, and this is T. Clear? So CR is equals to C dash R, and here you can see the length of BQ is more than length of B dash Q. BQ is greater than B dash Q. So here you can say day is longer, the duration of day is longer than duration of night. This is day and this is night. Clear? Likewise, the length of AP, okay, the length of AP is much bigger, right, than the length of A dash P. So here you can say that day is more longer, okay, right, in the towards the north pole of the earth here. Clear? AP is more longer than A dash P. Likewise, if we come into the southern hemisphere, then we will see that the length of DS, the length of DS is shorter than the length of D dash S, right? And likewise, the length of ET is much shorter than the length of E dash T. Okay, the length of ET is much shorter than the length of E dash T. So in southern hemisphere, you can see that the duration of day is very small right? Then the duration of night here, okay, ds is smaller than d dash s, and et is much smaller than e dash t, okay. So this much region is coming under night, and this much region is coming under day. Clear? So this variation in the length of days and night, okay, on different latitudes is just because of the inclination of Earth's axis, which is 66 and half degree. Clear? So I hope you would have understood this, right? And when in northern hemisphere the days are uh, longer than the nights, and in southern hemisphere the nights are longer than the days, then this variation in the length of days and nights will leads to what? Season. Okay, so what is happening here? Here uh, variation variation in the length or duration of day and night is there, okay, and which is leading to, right, which is leading to variations in seasons, variation in season. Why? Because northern hemisphere is receiving sunlight for more hours than southern hemisphere. This northern hemisphere is having days of more duration than nights. So the time period for which it is receiving heat energy is maximum than the time period in which it is losing that received heat energy. Okay, the time period for which it is receiving heat energy is more than the time period in which earth is losing heat energy, and because of that what will happen, more heat energy will be collected over these places, and it will lead to which season? It will lead to summer season. Clear? It will lead to summer season. And likewise, unlike here, here the opposite thing will take place, okay. And here the duration for which the sunlight or heat energy is being received is smaller than the duration during which it is being released by the earth, okay, during night terrestrial radiation. Clear? So here what will happen? Less heat energy will be trapped, and here the winter season will be experienced. Okay, so this will lead to changes in various variations. So we can see that the inclination of the earth at an angle of 66 and half degree is leading towards what? Towards the variation in seasons. 32 minutes are over. Now let me go fast. Now effect of the inclined axis on the duration. Now which we have studied about all these things. Now we will study about the effects. What is the effect of inclined axis on the duration of day and night? So the duration of day and night is not equal at all places. Okay, we have seen here duration of day is more than the night, and in southern hemisphere duration of day is much lesser than the duration of night. Then the time of the day at any place is determined by the height of the sun in the sky. That is the a method to determine the time, okay, by looking at the sun. When the sun is at the highest position in the sky, that time you can say it is the noon time, which is basically 12 o'clock, which is also called the meridional time, longitudinal time, or local time. Then we are having, if the axis of the earth was vertical instead of inclined, places on earth would have the same temperature throughout the year. This we have already, I have already demonstrated you, I have already explained you, okay, if earth's axis was straight, okay, in this manner, then all places would have received the earth, the sunlight for the same period, and the temperature remained same throughout the year. If the earth did not revolve around the sun, even then with its inclined axis there would be no season. Okay, so for season three things are required: rotation of earth, inclination of its axis, and revolution of earth around the sun. If earth is not revolving around the sun, if it is stationary at a place, then also we will not observe seasons, okay, that we will study while studying seasons. Now effects of the inclined axis on seasons, right? So on earth, this gives rise to changing seasons and varying length of day and night. Okay, that we have already studied. Okay, when the earth is inclined towards the sun, right, for particular period of time, suppose for 3 months it is, the earth remains in this condition, right, then what will happen, the places in the northern hemisphere will have longer days, and as a result more heat will be collected, okay, and they will experience which season, the uh, sorry, warm season, hot season, okay, summer season, right? And the places in the southern hemisphere, right, they will receive which season? They will receive the winter season, okay, they will experience winter season, okay. So it will lead, this inclination is leading to variations in the duration of days and nights, and hence in the variations of seasons. So this was all about the inclination of the Earth's axis. I hope you would have understood that. In next lecture, we are going to study about the revolution of the Earth, about solstices and equinoxes. Okay, thank you so much.